Fractal design cases have inspired modders all over the world who have built some amazing systems like this Dark Side themed case by George Purcellis showcasing the spacious internals in the Define S, or Metallic Acid, a mini ITX system by Justin Olson featuring a white, black, and red color scheme and a super clean layout in the Define Nano S. There are a ton more awesome builds like these on Fractal Design's modding series page, so check it out via the sponsor link in this video's description and get inspired for your next project.
Excellent!
How's it going, guys, and welcome to my Threadripper review. AMD's first ever high-end desktop platform launches today, and it's been talked about for months, so you're probably already familiar with the specs on screen right now. Today I'm going to be comparing the 16-core Threadripper 1950X to the 10-core Intel 7900X, because they both cost $1,000, and because Intel does not yet have a 16-core CPU in their X299 platform that's available, so I'm working with what I got. Let's get right into the testing setup though. So for the Threadripper system here, I have the AMD Ryzen Threadripper 1950X 16-core 32-thread CPU. I also got the Asus X399 Zenith Extreme motherboard. It's running the latest UEFI version provided by Asus, that's 0401. And for CPU cooling, I have the Corsair H100i V2 240mm all-in-one liquid cooler. Now note on CPU cooling, I used the TR4 bracket that came with the CPU because I wanted to see how middle-of-the-road 240mm Ace-Tech based cooler would work with this configuration, since I'm guessing that's what's the most common, and AMD does seem to be kind of banking on the fact that people will have these somewhat available to them. I also used a little bit of extra thermal paste to get as much contact between the block on the cooler and the extra large Threadripper heat spreader as possible to try to get maximum coverage over all four of those CPU dies, even though only 2 out of the 4 are actually functional. For a GPU though, I have the Asus Strix GTX 1080 Ti OC. It's running at the out-of-the-box manufacturer overclock speeds. For memory, I have 4 8GB sticks of G.Skill Trident Z DDR4 3200 memory in quad channel. The memory settings were manually keyed into the UEFI for both systems. Speeds are at 3200, timings are at 1414, 1434, and voltage is at 1.35. Finally, for storage, I have the Windows 10 operating system on a Samsung 960 Pro 512GB NVMe SSD, and then games and video files are on an external SanDisk Ultra 2 1TB SATA SSD, which is connected via USB 3.0. This system is powered by Roswell Tachyon 1000-watt 80+ platinum power supply, and as you can probably see, it's an open test bed. For the Skylake X system, I have very much the same configuration. Of course, different CPU, the Intel Core i9 7900X 10-core 20-thread CPU. For the motherboard, I have an MSI X299 Gaming M7 ACK. And then for storage, I have Windows 10 on the Toshiba OCZ RD400 512GB NVMe SSD. And then it's all powered by the Gigabyte Extreme XP1200M 1200-watt 80+ platinum power supply. Beyond that, everything is exactly the same between the systems, the memory kits and the memory settings. The GPU is the same, and I did swap out this Corsair H100i V2 over to the 7900X system for benchmarking, since that does affect thermals, of course. The GPU driver is the latest from NVIDIA, 384.94. Windows 10 is set to high performance mode for both systems, and I'm also running AMD's Ryzen Master software on the Threadripper system and Intel's Turbo Boost Max 3.0 on the Skylake X rig. Let's get into the benchmarks now, starting off with Cinebench, which is a test suite based on Maxon's animation software Cinema 4D. It can use all of the CPU's threads to render a scene, so the more cores and the more threads, the better the score. For multi-threaded scores, the 1950X definitely took the lead here with a massive score of 2,969, just shy of 3,000. 7900X came in at 2210, and then when possible, I'm also going to throw in the 7700K and 1800X benchmark results for you, so you have them for comparison. Now, single thread mode is also something that you can turn on in Cinebench, and it is a good indicator of how a CPU might perform while gaming or while running software that isn't multi-threaded like Cinebench is. The 1950X here shows its single threaded deficit when compared to Intel, score of 161 compared to the 7900X with a score of 192, and then finally that 7700K maintaining its single thread lead with a score of 193. CPU Mark is next. This is part of the Passmark benchmarking suite, and it runs a series of simulated tasks providing you with an overall score at the end. Here again we saw the 1950X dominate with a score of 24,405, followed up by the 7900X with a score of just shy of 23,000. CPU Mark also has a single threaded test that it runs, so I dropped that in here for you too. And again, we can see the same story. When you're looking at the Zen-based CPUs, the 1950X and 1800X, you're seeing relatively the same score, since these are running at relatively the same frequencies, around 4,000 to 4,200 megahertz. And then the 7900X and 7700K win in single thread mode once again. Next up is Blender, which is a free open source 3D creation suite that supports the entirety of the 3D pipeline, modeling, rigging, animation, simulation, rendering, compositing, and motion tracking. For my tests that I ran, lower is better here since this is just the time listed in seconds, and the 7900X actually won this test with a score of 25.7, despite not having as many cores or threads as the 1950X, which came in with a score of 26.2. This just goes to show you that not all software can take advantage of all those threads, and when it can't, the 7900X is going to regain a lot of ground on the Threadripper processor. Next is POV-Ray 3.7. This is a free 3D graphics software. It uses the CPU to compute ray tracing to render an image. 1950X dominates here since POV-Ray is very good at handling lots of threads and lots of cores. About a 30% lead over the 7900X with a total time of 44.2 seconds compared to the 7900X at 57.5. We move on to Adobe Premiere Creative Cloud. This is the video editing software that I use, and I'm rendering a 3-minute and 54-second 4K video in 3840 by 2160 resolution with a 40 megabit bitrate. The 1950X shows again that it is monstrous when it comes to content creation with a total time of 5 minutes and 15 seconds, beating the 7900X by about 30 seconds. 3D Mark Firestrike Ultra is next, a test you guys are probably familiar with. The overall scores are pretty similar here, but the physics score is more of the CPU test, and here we can see the physics score scaling up with more cores and more threads. The 1950X has a massive physics score of 26,896, and then the GPU test shows again that a little bit better single-threaded performance can eke out a little bit better performance from your graphics card. Moving on to 3D Mark Time Spy, a DirectX 12 test, which I don't think is optimized quite as well for all of those threads and cores, because even in the CPU specific test, the 7900X manages to pull out a win with a score of 11,600 versus the 1950X's score of 10,369. Now, a quick note before moving on to the last test, Grand Theft Auto 5. I did turn on game mode here utilizing the Ryzen Master software. Now, in Ryzen Master, you might notice a couple different options at the bottom: creator mode and game mode. Basically, this is an option AMD enabled to optimize specifically for gaming just a little bit. When game mode is turned on, two things happen. First off, legacy compatibility mode is enabled. I don't really like that name, but it means that one of your two Ryzen 8 core dies in the CPU is turned off. That cuts your number of cores and threads that are available in half, but it also eliminates the latency that is introduced in communicating between them. Now, since most games only use 4 cores at max, you don't really need all 16 of them for gaming anyway. And then the second thing is that memory access mode is switched to NUMA mode, or non-uniform memory access, so that each single core works with the memory that's directly attached to it rather than spreading it around and working with all of the system memory. Again, that reduces latency for gaming. A reset is required to switch between modes, but it did allow for performance on the 1900X that was in line with what the 1800X experienced. But bear in mind that I'm also benchmarking GTA 5 here at 1920 by 1080 to put more of the load on the CPU rather than the GPU. The 7900X in this case definitely actually had more choppiness. If you look, you actually see that those 0.1% lows, the slowest of all of the frames that were measured, the 7900X actually loses to the 1950X, and that was something that I actually noticed as I was running the benchmark. So overall, you got a higher average frame rate with the 7900X, but overall I would say the gaming experience was just a little bit smoother with the 1950X. Let's move on to power draw, and I just have some basic numbers for you here. At idle, we had a power draw of 105 watts for the 1950X. 455 was what it hit at peak, although it was typically drawing a lot less than that depending on what I was doing. To do some temperature testing, I ran the IDA64 stability test, stressing the CPU, FPU, and cache. The 1950X actually performed really well here, and I think this was partially due to the frequency it was running at, which we'll get to in just a second. 58C was actually the max that it hit. I was quite impressed, especially considering I'm only using a 240mm radiator, considering they shipped us all a 360mm rad in that Thermaltake unit. The 7900X actually got up to 74 degrees Celsius after about 20 minutes, so it was running pretty warm, although it was running at a higher frequency as well. Now, I've listed several different frequencies here for the 1950X as well as the 7900X. 1950X in game mode was running a little bit faster across, well, not all the cores because not all of them are enabled, but I did see about 3.5 to 3.6 gigahertz frequency. Now, Threadripper also has XFR, or extended frequency range, just like the mainstream Ryzen parts, and it'll actually boost up by 200 megahertz with Threadripper. So 200 megahertz on top of the max boost clock of 4000 gets you up to about 4.2 gigahertz, which isn't too bad at all when you're only running at 1 to 4 cores, and that is why in some of the single-threaded performance tests, as well as I believe in the gaming tests, we saw performance from Threadripper which was pretty much what you'd expect from an overclocked 1800X. The 7900X was also running quite a bit hotter, as we've already seen, but it was also running faster. When on all cores, it was running at 4 gigahertz just straight up, and it also has that peak turbo boost max mode that it will do on just 1 or 2 of the cores, and actually saw that hit 4.5 gigahertz max. Pretty impressive when you're talking about a single core out of 10 being able to achieve that just with the out-of-the-box settings. So just some final notes to wrap up about Threadripper in general. First off, in game mode, AMD tells us that it can improve game performance by 5 to 20% depending on the game that you're playing and how much latency might affect it. There are games that actually suffer from switching to game mode, so do take a moment to double check, and I'm sure as more reviews come out we'll see more actual tests in different games with Threadripper. The XFR temperature offset, if you guys recall, on mainstream Ryzen there's a temperature offset that tricks the system into thinking the CPU is hotter than it actually is. That runs the fans at a faster speed, lowering the temperature and allowing extended frequency range to extend the frequency range extend further, make it run faster. So it's plus 27 degrees for Threadripper, just in case you're interested. And if you're using Hardware Info 64, you can actually see both readouts. You can see the actual temperature as well as the offset, which is always going to be 27 degrees Celsius difference. And finally, I wanted to point out that AMD told us every single Ryzen Threadripper die is binned, and only the top 5% of Ryzen dies go into these chips. That means of all of the CPUs that they use for mainstream Ryzen stuff, as well as Threadripper, as well as the EPYC CPUs as well that are going into server stuff, the fastest 5% go to Threadripper. That means XFR is going to work better, and that means potentially we might see better overclocking. Overall though, I think the AMD Ryzen Threadripper 1950X is an absolute beast, especially when you're running software that can make use of all of those cores. It tears through workstation tasks, and I would definitely give it my recommendation. Remember though that not all tasks can use all of those cores and threads, and in gaming especially we can see that Threadripper does still fall behind Intel's best, even with gaming mode turned on. At higher resolutions like 1440 at 4K though, the gaming performance would level out between these chips, so that's definitely not a deal breaker, especially given these products' intended uses. They're more workstation parts than for gaming, although people are still going to use them to game. Also bear in mind that Intel's 7900X is running at higher sustained clocks, leading to higher temps, but also making up for some of that performance lost by it only having 10 cores rather than 16. I wasn't able to include overclocking in this video, but I will be coming back to that to see if running all of Threadripper's cores at 3.8 or 4 GHz can make a big difference. I'm also going to pit the 12-core Threadripper 1920X against Intel's 7820X, so subscribe to my channel if you're interested in those videos, hit the thumbs up button on your way out if you enjoyed this one, and we'll see you guys in the next one.